A hockey puck's average velocity is 22 meters per second. What is its displacement in 6 seconds? All right, so you're going to write your givens, and then you're going to write D0, D1, V0, V1, A, and T. Okay? And then you're going to go back and you're going to reread your problem and pick stop whenever you come to a given. A hockey puck's average velocity is 22 meters per second. Well, that's not the initial or the final velocity. That's the average. And what that really implies is that the velocity is changing, but if you take into account all the different velocities, the average velocity would occur throughout the whole problem. So really you can kind of put these together and you can just say that V0 is 22 meters per second and V1 is also 22 meters per second. Okay? And that means it has constant velocity according to this scheme we're using. Even though, it might change, we're not worrying about that. So we're going to write our time, 6 seconds. And they're looking for the displacement. That's delta D. If we decide that D0 is 0, in other words, if we put the starting point at the origin, then D1 is equal to the displacement. So our unknown is D1, or you can write delta D, which is displacement. D1 is the final position. Delta D is the displacement from the origin. So our equation, we look through our 4 equations. And there's our 4 equations. And you go through and you see, okay, we need D1. Do we know D0? Yes. Do we know V0? Yes. Do we know T? Yes. Do we know A? Does the velocity change? No. If the velocity doesn't change, then the rate of change of velocity is 0. So the acceleration, based on our scheme here, is going to be 0 meters per second squared. Okay? So you could use the first equation. And I'm going to write it down. D1 equals D0 plus V0 times T plus 1/2 A T squared. Okay? And then our substitution, D1 equals 0 meters plus 22 meters per second times 6 seconds plus 1/2 A 0 meters per second squared times 6 seconds squared. All right? And then if we do the math here, we got D1 equals 0 plus 22 times 6 is 132. So that's 132 meters. Plus 1/2 times 0 is 0. And 0 times 6 squared is 0. So it's 132 meters. Now, I want you to get used to doing this also, because we're going to be doing this coming up. We're going to draw a position versus time graph, a velocity versus time graph, and an acceleration versus time graph. Okay? So, if the object is moving with an average velocity, or we could say a constant velocity of 22 meters per second, then it's moving in the positive direction 22 meters every second. So if you start at 0, its graph is going to look something like that. And the velocity is constant. So it's going to be a horizontal line. And the acceleration is a horizontal line at 0.